So we started discussing on system softwares, mostly on your operating systems, which is, well, second half of this chapter is quite easy. It's like a general introductory of what's a operating system, what operating system should be doing, what is the major functionalities of operating systems. So it's not going to be that difficult. So let's discuss what we have discussed last class. Last class, we kind of do the review on how to write a program. They give you introduction on assembly languages, and that's eventually will be translated into machine level languages. Opcode and addresses are a common format of the assemblies that we can do. And there was an example on translating high-level languages like C and Python into an assembly, and I also suggest you guys that do a couple of practices on how to translate even for simple addition operation on high-level C into an assembly language, which usually takes more than a line in assembly because you're using a limited number of registers to work with. So naked machines and virtual machines, the environment that you are more familiar with is a virtual machines. And then we discussed it briefly on graphical user interface that we know. So this was a simple major functionalities of the operating systems language. Programs that you write, those systems must be able to understand. So we actually went through the entire cycle of writing program and how those program is translate, giving an order to CPU, and we know that now the entire step you're writing, your program will be compiled and using your compiler on other system software, become a assembler, assembly language will be also translated by assembler. Assembler will generate the machine code that is a instruction set to the CPUs that you're working with. Most of you having a CPU, probably Intel. 그죠? Anybody using the AMD CPU? 자기 컴퓨터에 혹시 AMD 쓰는 사람? 아무도 없어? Everyone is Intel? 옛날에 Intel CPU, Intel Inside 그런 로고 있었죠. 그죠? That's what it means. Memory management, operating system is also, they have to maintain the memories. We will discuss a bit more on the memory and virtual memory part. Basically, we try to give a space for each program. Operating system are responsible to give a space to each system. And if each program and one of the program terminate, then OS will retrieve that memory space for some other process to use. So those are basic things to discuss. Let me skip assembly language. I discuss assembly low-level program language, Java, C, Python, high-level program language. This is a simple map we discussed. And then this was one general process of creating object and loading into memory. Your program in C, assembly language, by assemblers, another system software will translate this assembly language into an object program, machine language, and then load it into memory, and hopefully your program start running at that point. Okay, I've discussed this a few times. So let me skip a few slides that we discussed last time. This, I also ask you to do a couple of practice on using, so you should be able to, maybe in the exam situation, I give a setup opcode that you can use. Maybe I give a table of these instructions, and then I give you a piece of code like this, and probably ask you to translate that piece of high-level language into the assembly code using the given opcode. That's a reasonable question for me to ask, and your assignment questions will be asking a similar stuff too. 시험 같은 데서 중간고사인지 기말고사인지 내가 까먹었고, 하여튼 시험 같은 데서 이거 이렇게 주고 여기에 you can use load, compare, jump, giving you setup of code, and then 내가 translate that into assembly language. That is a reasonable questions to ask. Do it. This is the bottom line, right? Instruction format, opcode 4 bits, address 12 bits. So this may be referring to a in, maybe same thing as store in X. 이게 in, 4 bits for in, this part for X where the X is located. So this simply translate into binary code. So I guess if you have a 4-bit opcode, I guess you're using a 4-bit CPU. How many bits? How many bits in your CPU architecture? The computers that you're using at this moment? 64 bits, right? 64 bits then simply means there are 64 digits to describe. See? This is simple 4-bit CPU or processor. CPU 아니다, processor, microprocessors, 4-bit CPU, 4-bit processors. They understand what these means. 그죠? 조그만 보드 같은 거 혹시 전에도 한번 물어본 것 같은데 anybody participating in 뭐냐 로봇 사커 혹시 동아리 한 명씩은 꼭 있던데 매년 로봇 축구 월드컵 로봇 축구 하는 거 그런 거 혹시 동아리 있는 사람 없어요? 없구나. 그런데 가면 요만한 프로세서들 되게 조그만 거 전기 조금 먹고 되게 단순한 무브만 할 수 있는 거 뭐 앞으로 뒤로 할 수 있는 거 이런 거 요즘에 C로 프로그램하면 이렇게 코드에 넣으려면 다 된다고 그러더라고. 옛날에는 다 어셈블리로 짰는데 요즘엔 잘 돼 있어서 C로 짜서 올리고 한다 그러더라고요. So you can certainly order those type of microchips too. 그런 거 인터넷 가면 팔아요. 요만한 CPU 조금 4-bit, 8-bit architecture. If you can even design your own chipsets and ask them to give you one. They probably send you over 택배로 다 보내줘 구워서. Okay, so operating system continues. System commands. System command user instructions about what computer should do. These are examples for the system command. Translate the program, run the program, or save information to a file, retrieve a file, list the files for this users. What's a command for list all the files in your directory? 리눅스나 이런 데서 list all your files under your directory. What is command name? ls or Windows for dir/w. Yeah, I don't know if they still use it or not. Those type of simple command are there to use it. Most of you guys don't use that command line mode. You guys probably open up in Microsoft Explorer to find the files, but there is alternative way to do it. Delete and rename files, copy. Those are the common tasks that you're doing every single day. 근데 if you think about it, the copying operation, renaming operation, those actually requires a lot of help from the operating systems too. 그냥 우리 일반적으로 카피하면 쉽게 생각해서 쉽게 된다고 생각하는데 사실은 상당히 복잡한 아래 오퍼레이션이 필요해요. Or let the user set or change a password. What happens if you forgot your password for your Windows desktop? 어떻게 해요? 그렇게 지우면 돼요? 요즘에? Anybody forgot their password on anything? 진짜? 아무도 없어? Or do you even have a password for your desktop or laptop? Smartphone. Anybody who has a password for your smartphones? 둘? Among 62? Password for your smartphones. Pattern. 뭐 pattern is also a type of password too. 다 있죠? 웬만하면 요즘에. Those are also crucial security features for your operating systems too. Your iOS, iPhone, or Android is also a operating system that we called. 뭐 많이 할 수 있죠. What you guys seeing is mostly GUI. graphical user interface or GUI. But what I usually use for a command line, I usually use for black screen only typing messages. So there's our two different types. So user interface, user communication with operating systems, blah, blah, blah. User command system software, blah, 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 is much easier. Graphical user interface, icons, and click. 이거 now you guys are so used to this designing that you don't see it as a wow. But when it first came out, a lot of people were impressed. 처음 나왔을 때 지금이야 여러분들은 워낙에 저걸 보고 큰 세대라 별 관심이 없지만 처음 나왔을 때는 이렇게 컴퓨터를 쉽게 쓸 수 있다니 막 그렇게도 했었어요. 옛날엔 다 손으로 커맨드 다 외워서 했어요. 지금도 많이 그렇게 해요. 나도 외웠었어요. 나도 GUI 잘 안 써요. 그 인터넷 서핑할 때 빼놓고는 잘 안 해요. 어떤 사람들은 인터넷 서핑도 그냥 텍스트로 다 하는데 blah blah blah, skip. So I give you a bit more detail on what's operating system. What is an operating system? A program that acts as an intermediary, stays between you and the hardware. That's why in your textbook, they're referring to an example for naked machines and virtual machines, right? Naked machines, there is almost no intermediary software between you and the hardware. Okay, I'm gonna go a bit fast, so you guys need some rest. I'm gonna go a bit fast. 이거 뭐 다 아는 얘기니까. Convenient to use. Current operating system in the world. Easy examples. How many of you have seen Windows 3.1? 이거. Have you guys seen this? 3.1 어떻게 생겼는지 알아요? Probably not. Before you were born. 아니다. You guys born in 언제지? 95년생? Before you guys were born. So it is before you guys were born. So Windows 95, you guys have seen? You have used Windows 95? 니네 95년생이라며요. 진짜? 짱인데. When Windows 95, a lot of blue screen, a lot of crash. It used to be a lot of crash. 이거는 Windows 3.1 was it also had nice graphical user interface. 근데 뭐 별로 할 수 있는 게 별로 없었던 거로 얼핏 기억해요. 나도 어렸을 때랑 뭐 끼케야, 지뢰찾기? 뭐 이런 거 했던 것 같아요. 그때부터 지뢰찾기는 있었던 것 같아요. But Windows 3.1 simply what might be the major difference between the current Windows that you're using. 이때는 Windows 3.1 only one program at a time. Now it seems like many programs running at the same time, 그죠? The Windows 3.1 is simply very similar to a DOS. So that was a major difference. And Windows 98, probably many of you have seen it. There was a lot of versions in the between Windows ME, 뭐 별의별 게 많았었는데. And then it goes to Windows NT, Windows 2000. 이거 probably not many of you have experience in Windows NT. It's a Windows, but the architecture is completely different. It's a server use. 이름은 윈도우인데 여러분들이 쓰던 윈도우랑은 사실 안에 생긴 거 완전히 틀려요. 겉만 비슷하고. And then Windows XP finally stopped using it in April a few weeks ago. How many of you still Windows using XP? Not many, right? Windows 7 probably most, and Windows 8, you guys are using it. I'm just simply bring up Windows because this is more familiar operating systems that you guys know. Have you guys tried to install a operating system? 윈도우 새로 깔아본 사람 혹시? 많이들 해봤죠? 리눅스 깔아본 사람? Okay. Was it easy? It's almost same as Windows, right? And then a long time ago, when you try to install Linux, it was so painful. 요즘에 그냥 CD 넣고 USB 굽고 해가지고 넣으면 윈도우 까는 건 똑같지만 옛날에는 you have to set up all the disk spaces, swap spaces. You have to type it up, and That's why a lot of people didn't like it. Also, their UI was very bad looking. 아이고, 웬일로 내가 전화기 가져왔네. Okay, Windows XP shut down. Windows 7, I forgot the date, but when do they? Windows 7은 언제 close 한다 그랬죠? I forgot the actual date. Maybe next 5-6 years, they will also shut it down. Windows 7 again. 그러니까 we're gonna actually going through this cycle over and over again. So this goes down and this path, and the exact opposite graph going up. That's how much Bill Gates makes money. 니네들이 다 사주는 동안에 빌 게이츠는 1초에 페라리를 한 대씩 살 수 있을 정도의 돈이 계속 들어오죠. 우리나라만 해도 다 윈도우니까. 뭐래더라? 95% of the Korean computers in Korea are running Windows, even including the older government. Linux. So other than Windows, there are many different types of Linux. You can see. If you really know nothing about Linux, I would suggest go for Ubuntu. Ubuntu free, you can download, and usually there isn't many things to do. Or Fedora is also okay. You got all different type of Linux. Red Hat, SUSE, Mandrake도 아직 있는지 모르겠다. Anyway, all the penguins similar looking. In the Europe, a lot of people using Linux. 유럽이나 미국은 맥이 더 많고, 미국은 우리보다 맥이 훨씬 많은 것 같고, 유럽은 가보면 리눅스가 대부분인 것 같아요. So that's my suggestion. So you can just pick one and try on your own. No guarantees. Back up your data somewhere else. Is there only Linux? No. There are other ones too. 혹시 저거 본 사람? Little Devil, Red Devils. 저 operating system. Anybody seen that operating system before? BSD, FreeBSD, NetBSD, OpenBSD. It's also other type of operating systems. 여기는 죽이네. This Red Devil tried to kill the Penguin Linux right there. 그죠? 둘이 싸우나 보지 뭐. They try to kill each other. Anyway, also your big website that you're using every single day, they don't use, some of the big website, they don't use Windows, they don't use the Linux, they sometimes use NetBSD, these type of ones. 이런 거 많이 써요, 실제로는 operating system 할 때. If you install those BSD type, it's all black screen, no graphical user interfaces, no fancy instructions, so you have to learn it as well. Usually developed by hackers. 이거 개발하는 사람들은 몇 명 안 되더라고요. 근데 1년에 어디 맨날 이런 데 어디 이상한 음침한 도시 막 이런 데서 만나가지고 저번에 얘기한 거 다 개발했니 안 했니 막 이런 거 1년에 한 2번 정도가 만나는 걸로 내가 기억하는데 그 안에 들어가기는 상당히 힘든 걸로 알고 있어요. 몇 명 안 되는 걸로 알고 있어요. 그 이상한 애들 막 머리 막 여기까지 오고 남자애들이 막 머리 여기까지 오고 막 뚱뚱하고 막 이런 애들 하루 종일 앉아서 코딩하는 애들 그런 애들이 저런 거 짜더라고요. NetBSD도 한번 FreeBSD도 한번 깔아봐요. It's not too bad. You can do it. Or if you don't want to destroy your data in your computer, then you can certainly use a virtual box. Like I heard, I don't use VMware, but I heard if you use a VMware, then you can even play 3D games too. 아마 3D 게임까지도 지원한다고 그러던데 VMware 하면. 네, 그래서 VMware 비싼 버전은 그래서 많이 써요. 좀 싸구려 돈 안 내는 버전들은 그런 게 지원이 잘 안 돼. It's a small software that create a virtual environment that you can install another operating system on top of different operating systems. So it's like on top of Windows you can install Linux. 내가 여기서 숙제를 그걸 안 내줬지. Your second year course, probably if you take it with me, I will ask. The assignment 0 is like that. I usually ask them to install VirtualBox and install Linux of your choice and do it. You can even install other type of operating systems too. The FreeBSD는 if you install FreeBSD, you will not know what to do after that. 여러분들이 보는 OS가 아니라서 처음에 딱 깔면 이거 뭐라는 거야? 막막할 거예요. But just to see what's happening, it'd be nice. And our favorite Mac. I think my first ever OS experience in Mac was 대학교 1학년 딱 들어가서 first year of my course 대학교 1학년 딱 들어가서 컴퓨터 과목 딱 들어갔더니 맥 딱 있었어요. 그때 처음 맥 써본 것 같아요. 그 실습실 우리로 말하면 실습실이 다 맥이었던 것 같아요. 지금은 다 버렸겠지만 it was okay. I mean, Mac, Apple, Mac OS, old type OS, MacBook Air, blah blah blah. iPad, iOS is the Mac version of the mobile device operating systems, right? There are a lot of issues on this part. Some people blame why there are so many viruses for Microsoft Windows, and there seems to be no viruses for Mac. Well, it's not true statement actually, because a lot of people using more of a Windows, it seems more trouble with the Windows. It doesn't mean the Mac OS is safe. 그런 얘기 많이 하잖아요. MS 윈도우는 쓰면 웬 바이러스도 이렇게 많고 뭐 그런데 그렇게 얘기를 하는데 맥도 비슷해요. 똑같아요. 단지 사용자가 윈도우가 훨씬 많다 보니까 그렇게 더 느껴질 뿐이에요. So I just wanted you to know there are many different operating systems. I'm using my desktop is Mac. My VirtualBox is Windows just because I have to go into a school system, and I have iPad, iOS. My cell phone is Android. I have 2 Linux boxes, so I'm using at least 5 different operating systems. If I use a cloud, then you can add 2 more, 1 more. 나는 OS만 5가지 다른 걸 쓰는 것 같아요. 왔다 갔다 바꿔가면서. 별로 좋은 건 아닌데 어쩌다 보니까 그렇게 되더라고요. How many operating systems do you guys have, do you think? 몇 개나 될까? 생각보다 많을걸요? 자기 데스크탑은 윈도우일 거고 다 핸드폰, 스마트폰이니까 거기에 OS 다를 거고 집에 있는 거 다를 거고 최소한 2-3가지는 될걸요? 하물며 전자레인지에도 OS가 들어가는데 작은 OS가 들어가는데. So computer system structure, hardware, we know that it consists of CPU, memory, I/O devices, operating system, coordinate the use of hardware among various applications and users. So you have to have an operating system in order to use a program like Microsoft Office. Application program define the ways in which system resources are 참 망가지겠다. Used to solve the computing problems of the users. Just your programs that you use. Word processor, compilers, web browsers, database systems, video games. Anybody using PlayStation? I don't know what kind of operating system is on top of PlayStation. 나 잊어버렸어요. I don't know. Maybe Linux-like as well. Users, blah blah blah. Skip it. What operating OS can do depends on the point of view. Users wanted convenient, ease of use, don't care about resource utilization. Just normal users like us. We don't really care how much memory it takes, how much CPU time it takes. We don't usually care. As long as it works, then we're fine. 그죠? But if you get to know a bit better, then sometimes you wonder why my computer is sometimes slow. Then they usually go for memory usage of your processes running in your system. Shared computer like mainframe or mini computer must keep all users happy. 이거 mainframe is like a big computer and your PC is just there to access them. They use the term mainframe, but simply put as cloud. Simply put as cloud. Have you been to Amazon's EC2 service? Like 보여주나? OS 시간에 보여주나? If you go into Amazon 뭐예요? What does Amazon do? 그죠? Many people know that as much as selling books and shopping site. But actually Amazon provide a lot of different cloud service well, similar to this. You can actually go into Amazon website and buy a operating system. Then you can access your own machines in Amazon server. So a lot of venture companies nowadays, instead of buying their hardware computers, they actually buy their own machines from Amazon's cloud service. 옛날에는 뭐 회사 차리고 하려면 컴퓨터 이렇게 사서 리눅스 깔고 막 이렇게 했는데 요즘엔 그렇게 안 하고 아마존 EC2 이런 웹사이트 들어가면 OS를 살 수가 있어요. 시간별로. 한번 볼까? Yeah, Linux, this is how much money they ask for in order to borrow a Linux. This is from East Europe, US is 미국 동부 쪽. So $0.07, that's how much is in Korean won. 1달러가 얼마지? 1,000원? Maybe 0.07불이면 얼마야? 뭐 한 100원? 뭐 이런 수준인가? 그 정도 되나? 100원도 안 되나? 100원 수준? So that's how much they ask for. So you purchase your Linux server, and this is your Linux combination. Let's say there's one virtual CPU, your machine. You have one CPU, I don't know what ECU was, I forgot. Memory, there's 3.75 giga of memory. It's like your desktop. In order to borrow this machine, that's how much money they ask for. So if you purchase that, then you have your machine to log into. 깔 필요 없어요. You don't need to buy the hardware. All the data set will be backed up. Let me see. 근데 이거는 from a 어디야? 저쪽이니까 미동부니까. If you try to access from the Asian region, they probably charge you a bit more. 조금 더 비싸게 받을 거예요. 일본도 좀 싸게 받는데 일본보다 우리가 조금 더 비싸게 받을 수도 있어요. 왜냐면 서버가 다 미국 쪽에 있을 거니까. 그죠? Sometimes you can even borrow this 32개 CPU, 32 CPUs, and 60, 저건 얼마였지? 60 terabyte? 아니다. 저 뭐였더라, 62? 60 memory, 60 gigabytes of memory, I think. And then this is how much they ask for. $1.60 per hour. $1.60 per hour. If you do a 24-hour access, then what? More. How many hours do you work? 8 hours a day. 그죠? 한 8시간 곱하면 maybe less than $15, then you can have your machine's access. So it's less money to spend on it. 다 가서 사면 돼요. 물론 우리는 좀 더 비싸게 받아 먹을 거예요, 얘네들이. 그거는 리눅스고. 윈도우는 얼마인지 볼까? Windows. Slightly more, I guess. Almost same, but a bit more expensive. Let's see. 아시아 퍼시픽 도쿄에서 얼마인지 보자. 도쿄는 좀 더 싸네. 좀 더 비싸네. Linux, how much it takes to use Linux on Tokyo. 한국은 없다, 그지? It's a bit more expensive from the spaces. So that means they actually say like you can buy operating system instances. You can try on it too. 요즘에 너무 바뀌어서 이건 GPU도 있다. GPU 인스턴스도 있다. 저건 더 많이 받네. So you can actually buy the operating systems in this way too. So think of it as mainframe is today's cloud. That's probably easier to understand. Users dedicated systems such as workstations have dedicated resources, but frequently use share resources from the servers. Your 실습실 above, 아마 they all running a Windows, independent Windows, right? Imagine that those computers hooked up to a main station, mainframe, big computer. Then you can just have an access to it. 어쩔 때는 큰 컴퓨터에 메모리랑 CPU 많이 붙어 있어서 여러 사람이 붙어서 그걸 나눠서 쓰는 거예요. 일반적인 시스템은. 클라우드도 비슷한 개념이죠. 그죠? 여러분들 앞으로 벤처 하고 싶으면 굳이 많은 투자금이 필요치 않아요. 아마존에서 한 달 접속할 수 있는 비용만 들면, 그러니까 뭐 한 달 접속해 얼마나 하겠어? 얼마 안 하겠죠? 돈 100만 원도 안 할걸? 한 10만 원이면 한 달 내내 접속해도 될걸? 그죠? 그러면 벤처 할 수 있어요. 옛날처럼 뭐 할 필요 없어요. 내가 듣기는 요즘에 다 이렇게 한다고 들었어요. 많이들 이렇게 해서. 사무실도 진짜 조금 옛날에 막 사무실 만들면 기계 갖다 놓을 때도 있어야 되고 했었는데 요즘에 저런 식으로 하면 얼마나 편해. 여러 사람이 동시에 접속할 수도 있고 하니까. Once you type in your user ID and password, then you can become a super user. Same term is being used in Windows like administrator. 그죠? When you are administrator, what can you do? administrator면 뭐 할 수 있어요? 수정. Yeah. It means that you can pretty much delete any files that is created by other people too. You have full access. So it's sometimes called as a super user. In Linux, they call it a root. 뭐라 그러지? When you do a iPhone, you try to jailbreak라고 그러나? Jailbreak 맞나? Rooting. So for Android, they call it as a rooting. 그죠? Rooting is what? 탈옥. 아이폰 탈옥. 아이폰은 탈옥이라고 그러고 아마 안드로이드 계열은 루팅이라고 그러지 않나요? 둘 다 그래요? 뭐라? 아는 줄 알았지. 아마 내가 알기로는 뭐 맞아요. 둘 다 루팅으로 맞아. 아이폰의 탈옥이란 말은 아이폰에서 처음 나온 말일 거예요 아마. 예. 그 전에 이제 뭐 이제 다 통틀어서 루팅이라고도 하는데 루트라는 게 슈퍼 유저 얘기하는 거예요. You become a super user. So they lock some functionalities. So jailbreak means I break it out from that loop. I become myself. I become a super user. I can change whatever I want in my system. So iPhone usually they don't provide that functionality. So that's why a lot of people jailbreak. What do you do when you do a jailbreak in iPhones? Pre-app. 맞아요. You can delete the apps, right? Pre-install apps. That means you are a super user. You can delete anything that you want. 똑같은 얘기죠. You can also install any program that you want. That's what it means to be jailbreak or rooting. It means they have a higher privilege. 권리가 높아지는 거예요. 나는 안 해서 모르는데 I don't do a jailbreak or rooting. Can you get a service after do a jailbreak? jailbreak 하고 나서 AS 받을 수 있어요 요즘에? 있어요? 응? 네. 풀고 나서는 해줘요? AS? 그래요? 흔적 지우면 완전 해커들 하는 얘기죠. 내 흔적을 지워가지고 서비스 받고. 맞아요. Or sometimes you do an encryption of the data of your system. Anybody doing an encryption often in your systems? 잘 하나? encryption 잘 안 하죠. If you using a Galaxy series or any Samsung's Note, then if you do a recent update, then there must be some applications that you never seen it before. 아마 최근에 업데이트하거나 시스템 업그레이드하는 사람은 갑자기 희한한 앱이 생겼을 거예요. 삼성 녹스. 지금 혹시 갤럭시 가지고 있는 사람 녹스라는 어플리케이션이 깔려 있는지 한번 찾아봐. 어떻게 스페링이 맞던가? 자기가 깐 적이 없는데 갑자기 깔려 있을 거예요. 뭐, 개기는 거야? 안 찾아보는 거야? 아마 자기는 쓰는 메뉴 없고 어디 숨겨져 있을 거예요. 뒤쪽에. 전체 메뉴 쪽에. 없어? 업데이트를 안 하는구나. 있어요? 아마 대부분 자기 깐 적 없는데 깔렸죠. 업데이트하고 나서. 이건 뭐 하는 거야? 뭐 하는 거예요? 그래요. 무슨 말인지 참 애매한 말이잖아요. 그죠? They doing this. Encryption. 암호화. If you want, you can use a Nox to encrypt your data in your mobile phones. or if you enable Knox, then I think if you lose your phones, then sometimes they can protect your data or delete your data, something like that. 녹스 이래가지고 삼성 녹스 찾아보면 자기 가지고 있는 핸드폰 안에 있는 데이터 전부 다 암호화 시켜갖고 저장하고 있는 거예요. 그래서 잊어버려도 딴 사람이 와서 풀지 못하게 많이 하죠. 셀폰 깜짝이야. 나도 녹스는 잘 안 써요. 근데 뭐 저번에는 그룹이 들어오더니 오늘은 솔로가 들어와서 깜짝 놀랐네. So if you're interested, you can certainly take a look. Encryption is common protective mechanism in your operating system. Well, one obvious protection mechanism is password and ID. A while ago, a lot of computers had the fingerprinting access right too. 그죠? 그 지문으로 컴퓨터 로그인하고 막 그런 것도 좀 있었는데 요즘 컴퓨터는 잘 안 달려 나오지. 그 한동안 유행으로 달려 나오다가 아니면 은행 웹사이트 같은데 지문으로 로그인하고 수 있었는데 여러분들 아마 고등학교 때 하다가 요즘엔 없어졌죠. 관심이 없구나. 은행 계좌는 있니? 이렇게 있었어요. 그 컴퓨터 마우스 붙어 있는데 터치패드인데 이렇게 하면 지금 아니 터치패드 앞에 이렇게 스캐너가 조그맣게 붙어 있었어요. 이렇게. 그 혹시 아마 요즘에 사는 컴퓨터에는 그게 또 다 없어졌어요. 뭐 그럴 수도 있어요. 델 같은 데는 아마 그럴 수도 있어요. 근데 그 원래는 많이 들어가다가 요즘에 다 뺐어요. Why? 핑거프린팅이 부정확해갖고 내 친구 거 이렇게 내 손가락으로 이렇게 로그인이 되고 막 그랬었어요. 한동안. 요즘에 아이폰 5가 무슨 지문 인식 그래서 뭐 그런 다음에 그거 뭐 조금만 잘못하면 그냥 뚫린다 그러더라고요. So such functionalities must be supported by operating systems too. Folders and file have authority list. So certain files that you can only view, you can delete, you can edit, modify. Each file have a different permissions. They call it as permissions. 대부분 여러분들 컴퓨터를 혼자 쓰니까 잘 모르겠지만 여러 사람이 쓰는 컴퓨터에서는 자기 디렉토리만 볼 수 있어요. 일반적으로 자기가 만든 파일만 볼 수 있고 슈퍼 유저는 다 볼 수 있고 그래서 자기가 만든 파일만 지울 수 있고 다시 고칠 수 있고 뭐 이런 기능들. Those are common stuff that you can see. These are it's okay. So operating system, the one thing the operating system wanted to do is keep your CPU busy. Keep your CPU busy. We have take a look at the CPU usage of this computer right here. 그죠? 전에 봤죠? They usually less than 10% all the time. But operating system, if operating system is good, you have a lot of programs to run, then make it busy. Make it busy. I don't want my CPUs to do nothing. Operating system as traffic, it's okay. Multiple programs active one time. Every program is one of the three states. Actually, every program it seems to be running all the time, but actually one program at a time running. So program have this type of state, running state, waiting state, ready state. So if I click on the Microsoft Office, as soon as I click and typing on the whatever I wanted to type in, it's a running state. And let's say I also wanted to watch a movie at the same time. Okay. Maybe on the side I open up a Go player to play movie files. So this Microsoft Office Go player keep running and waiting all the time, switching between the two. So when they're running, they get the time from CPU. When they have a CPU, it means CPU is doing something to doing a computation to work, running the programs, it's waiting for I/O operation. This is a bit difficult, but this three states is good enough for us. 이게 너무 일찍 나왔구나. 나중에 나와도 되는데 책에서. I/O bound process 이거 안 했죠? I'm gonna skip this. I/O bound process. Sometimes multiple programs are running at the same time. They have to share the memory. They have to share the CPU. Certain cases you're running into a situation called deadlock. Deadlock. It means because these programs are sharing the resources, sometimes a program's waiting for something, which never gonna happen. So all the programs are stuck, not doing anything at all. Deadlock situations also referring to 이것도 맞는지 모르겠는데. When I explain deadlock, I usually explain this way. 이렇게. Not me. I think this was one of the examples for the deadlock explanation. 이거 뭐야? 사거리. 사거리라고 쳐요. Four-way 해야 되는데 four-way가 뭔지 모르니. Car. Going this way. Car. Going this way. They're so nice. They're so nice. So they're waiting for each other. One of them must be going through in order to either this one goes, then this one can go. But these two cars are so nice. So waiting, this one go first. This one also waiting, this one go first. So every process is stopped. So think of this as a program 1, program 2. Program 1 and 2 are waiting for some memory space. Memory. They need some data. But they're waiting each other. Never gonna happen anything. And nothing's going to happen. Deadlock situations. Deadlock situations. 이렇게 되면 아무것도 안 도는 거죠. No process can be running. Or there is a very famous synchronization deadlock examples. 그런 거 있었어요. 이게 I think it's philosopher's diner problem. 이거 뭐더라? People let's say these are philosophers. Philosopher, what is a philosopher? 뭐지? 철학자? 뭐 그런 거죠. They don't do much, but they always think. They sit around. 그 비디오도 찍는데 괜히 이런 얘기 갖고. They sit around the table, and there is a food. And they all wanted to share a food. Their job is to finish this food as soon as possible, as fast as possible. But problem comes, in order to eat this food, they need a chopstick. But there is only one chopstick in the between. Chopstick, chopstick, chopstick. In order to this guy to eat this, they need both chopsticks. This one needs both chopsticks. It means then these two cannot eat while this one is eating. Same thing, this one. I like to eat this, so I need both chopsticks. Sometimes I wait for, this guy has this chopstick, I'm waiting for this chopstick. This guy maybe never doing anything. Or every philosopher is so nice that they don't want to pick up their chopsticks. No one is eating at all. Huh? 그럼 뭐하러 찹스틱을 해? 포크를 하지. 포크. Yeah, so there are solutions to. Well, if you wanna do that way, okay. Yeah, deadlock. So someone is waiting for something to happen, but I need to finish this food. So what might be the possible solution to remove any deadlock? Here. 여기서 you wanted to solve this situation. There must be some kind of algorithm to waiting for each other, but I like to remove any deadlock situations. Solutions. Even so, there may be again, they take the turn. Easy solution? Easy solution? 그렇지. You kill this one. Very easy solution. To kill one of the process and hoping for the others are nicely share something. 그치? 이거 actually is one of the solutions. When you're doing your computer, sometimes your programs are slow. What do? You kill one of the programs too, right? It's the same idea. Sometimes it may be a deadlock, sometimes it may not be a deadlock. Using too much memory, maybe one program using too much memory, I just kill it. And hopefully problem solved for the others as well. 그렇죠? 나중에 이거 프로그램 하라 그래요. 그러면 되게 웃겨요, 나중에. 아무도 못 먹어요, 시작해갖고. 아무도 못 먹고 끝날 때까지 하나도 못 먹어요. 어떤 케이스가 있을까? 얘만 먹어요. 얘가 다 먹어요. 나머지는 계속 기다려요. 별의별 케이스가 다 나와요. 이제 중간에 그러다가 갑자기 다 멈춰 있는 경우, 데드락이라고 보면 돼요. 이거 프로그램하면 재밌겠지? 죽을걸요? 머리가 빠질 것 같아요. 디버그가 안 돼. 어디서 스탑했는지 알 수가 없어요. 왜 스탑했는지. 여러분들 프로그램 짜면 지금 가면 다 이게 시퀀셜 오퍼레이션 했잖아. 라인 1부터 1, 2, 3, 4 쭉 내려오면서 그냥 숫자가 나가면서 하면 되는데 이건 그게 안 돼. 각자가 다 빠르게 동작하니까. 어디서 데드라이 걸리는지 잘 몰라요, 일반적으로. OS operating system usually cannot tell whether something is deadlocked or not. So one of the simple solutions from the OS is kill certain programs while it's running. 내가 대학 때 가장 싫어했던 프로그램 숙제가 이거였던 것 같아요. 지금도 보면 토할 것 같아요. 내 거는 잘 기억은 안 나는데 아마 내가 너무 짜증나갖고 먹다가 판을 엎고 나가는 걸로 했던 것 같아요. 먹다가 에이씨 찹스틱 다 부러뜨리고 막 이랬던 것 같아요. 오주가 안 돌아갔어요. 좀 사조이긴 한데 저것도 족보가 이렇게 쫙 있었어요. 이 프로그램 어사이먼트는 워낙에 오래전부터 나오던 문제니까 이런 개념을 알려주기 위해서는 족보가 막 있어요. 10년치 족보가 쫙 있어요. 10년치 프로그램 족보가. 다 틀려. 10년치 보고 베낄 수가 없어. 다 틀려가지고. 그래서 내 대에서 족보를 딱 끊어버리고 내가 다 불태워버렸어요. 내 후배들한테 안 줬어요. 그러고 그랬어요. 어차피 있어야 하지 못한다. 그리고 전설을 남기고 내가 그냥 도망갔지. 이거 할까? 이거 우린 아직은 이건 좀 무리고 한 3, 4학년 때 가능하면 이건 할 거예요. Multiple programs requesting. Hopefully that gives you idea for deadlock situations, synchronization problems. Multiple programs are requesting access to the resources. Deadlock occurs when all programs have some resources and waiting for resources to be held by the others. This one have an access to these two chopsticks. This and this waiting for resources. Here resources mean chopstick. So sometimes those situations continues, then hopefully not. Deadlock preventions. What can you do that we can avoid such situations? Operating system dealing with the multiple programs. So we like to minimize such cases that occurring deadlocks. Simple prevention ideas. If you can get an all access resources, release all you have, and try it later. 없으면 just wait, try it again. Or there is also very dumb approaches too of doing this. 여기서 데드락 프리벤션 하려면 어떻게 하면 돼요? 여기서 간단하지 뭐. Add one more chopstick. Maybe not all of them, maybe in this way. Just add one more, we'll solve a problem a bit better. 그죠? Simple ways of doing it. 뭐 그럴 수 없는 경우도 많겠지만 sometimes it's impossible to add more resources, but that's just one of the ideas actually to do it. 저게 여러분들 컴퓨터로 따지면 뭐가 될까? 그래요. 램 사서 끼우는 거지 뭐. 그렇게 쉽게 생각하면 아주 간단하죠. 램 새로 사서 2테라란다. 2기가 4기가로 늘리고 뭐 그것도 하나의 방법이 될 수 있어요. Deadlock recovery. If no acknowledgement, send message again. Keep asking. Sometimes you need to break this loop continuously. 내가 학교를 가서 저 숙제를 받고 가장 후회했던 것 같아요. 아씨, 내가 왜 이과를 봤을까 하고 막 3학년 때 2학년 말인가 3학년 때인가 자괴감을 들었던 거 막. 밤새 앉아 있어도 모르겠지. 막 설명은 쉬운데 뭐 찹스틱이고 뭐고 구현도 안 되겠지. 막 이러니까 되게 막 고민을 많이 했던 것 같아요. 이건 그냥 읽기만 합시다. Historical development operating system. First, nearly naked computers. The 0101 ways people have to actually do their program. Second generation is batch operation system. Programmers give a programmer to operate. Programmer collect a batch of the programs. 그냥 뭐 they give an instruction and computer reads it and do it. 그건 batch고 이거는 0101부터 처음부터 프로그램하는 거. 이건 뭐 그냥 as your knowledge. It's not important. 그것도 뭐 그치 테이프 같은 거. 옛날엔 테이프에 구멍 내서 0101 막 이렇게 할 때는 배치죠. 테이프 쫙 하면 프로그램이 거기 다 써 있는 거예요. 그래서 테이프를 쫙 읽으면서 프로그램 읽어가면 그게 배치예요. 우리는 지금 프로그램 어떻게 런해요? How do we run our programs? We store them into a memory and then execute. 그죠? This time they didn't do it. As soon as whatever they need, they had to run it every single time. Batch process, batch programs. 몰라도 돼. 여러분들은 평생 가도 볼 일 없을 겁니다. So third generation multi-programmed operating systems. Multiple programs loaded at the same time. Our memories are usually big, a couple of gigabytes, even more. So we can have multiple programs loaded into memory at the same time. Just switching between each other. That's the magic of looking at like a simultaneous programming. 내가 전에 얘기했죠. If you're thinking that it looks like multiple programs running at the same time, it is actually not. Only one process at a time, but they're switching so fast that you feel like that they're running at the same time. So, well, it's the same idea of has 뭐냐? 디지털 카메라 같은 거 사면 if you try to take the movie files they usually say 30 frames per second or 60 frames per second. 그 무비가 30 frames per second 30장에 초당 30장의 그림이 지나가니까 영화처럼 보이는 거 아니에요? 똑같은 얘기예요. But there is a lot of different pictures switching around. So it looks like all running at the same time. 그래서 가끔씩 보면 컴퓨터 느려지면 뭐 이렇게 아래에 있는 거 클릭해서 딱 올리려고 그러면 쭉 올라올 때 더 이렇게 올라오죠. 서로 이제 막 바꿔대는 게 조금씩 느려져서 그러는 거예요. 마우스도 가끔씩 이렇게 좀 버벅거리면 마우스 이렇게 끌고 오면 꼬리가 이렇게 쭉 보이죠. 바꿔지는 게 좀 느려져서. Switching between programs and when I/O happens. Computer security is now required. Privileged operation only available to administrator. Bound memory program can legitimate access. This is what you're seeing nowadays for the hacking instance. System down, 그런 거. How can you protect your memory space from some other program? Usually, if I run a program, memory locked. The program is given that memory section only. Hackers actually try to access that into a memory space without your permission. 그래서 해킹 요즘에 막 많이 나오는 바이러스니 그런 거 많이 하는 거고. Privilege operations only available to administrator. Time sharing, also third generation. Multi-programs but used on the system interactively. Switching, time slicing, that's what I meant. It's okay. Network operation system. The operating system supports all the same local services, allow support services that access the resources that are available the network, blah, blah, blah. 뭐 이상한 거 많죠? There is a cloud printer. 클라우드 프린터라고 써본 사람? 구글 클라우드 프린터인가? Anybody can share a printer over the internet, then you can print out your stuff on someone else's printer. Or Chrome OS. 혹시 크롬북 써보는 사람? Anybody has a Chromebook? 크롬북 아직 우리나라에 안 팔 거예요 아마. Chromebook, Chrome OS. So instead of having the operating system installed on your laptop, actually your operating system is on the internet. Like your web browser will be your operating system menu. 크롬북 다 우리나라에서 나오는데 뭐 LG, 삼성에서 크롬북 만드는데 우리나라에서만 안 팔죠. 크롬 OS라고 구글이 만든 OS, 근데 웹 OS예요. 여러분처럼 컴퓨터에 깔리는 게 아니라 그런 것도 있고. 뉴스 좀 읽고 살아라 제발. 그죠? IT 계열 학생들이 이렇게 소식이 얻어갖고 어떡해요? 그것도 벌써 한참 된 얘기예요. 2년 전, 3년 전 얘기예요. 크롬 OS 나오는 것도. Real-time operating system or embedded systems? Real-time operating system, what is it? When I was in university, there was one room with trains only. It's called real-time operating system course. So in that room, there is a small train that is running. 그런 거 있었어요. So for one semester, your job is to move that train, making on top of the real-time operating systems. 우리 대학 때 다닐 때 그런 방이 있었어요. 철도방이라는 방이 있었어요. 우리끼리 보면 트레인룸이라고 그랬는데 이렇게 아무나 못 들어가고 그 코र्스 듣는 사람들만 들어갈 수 있었어. 이렇게 키가 있어가지고 가면은 이렇게 모형 기차 있잖아요. 실제로 진짜 움직이는 기차가 막 이렇게 산 같은 모형이 막 돌아다녀요. 한 학기 내내 하는 일이 그 리얼타임 오퍼레이팅 시스템에다가 그 열차를 움직이게 하는 거예요. 열차 움직이게 하는 게 한 학기 내내 하는 거예요. 첫 번째는 열차 움직이고 두 번째는 열차끼리 안 부딪히게 하고 막. 근데 맨날 다 부딪혀서 다 죽어요. 열차끼리 쾅 부딪히고. 우리 KTX 같은 거 그런 거 들어가는 오퍼레이팅 시스템, 시그널 시스템 같은 거. I can explain more in the next class. 다음 시간에 좀 그런 거 얘기 좀 재밌는 거 더 해줄게요. OS 부분은 그렇게 어렵지 않죠? 어렵게 안 할 거니까. Okay, I'm gonna stop here today.